We've lost an area of ice the size of Texas, north of Russia in the Arctic Circle. And it's not Russia's fault, it's the warming Atlantic flows there. And even with the pretty much constant 20 degrees below zero Celsius, which is 40 degrees below in Fahrenheit, but even with that cold moving over that water, it's not enough to gain ice. We are, they're just, the massive warm is too much. It just keeps radiating up through where it's trying to make ice. So you may be asking, who am I to be stating that I know two ways to build ice there? Well, I happen to have raised trout for several years in upstate New York, and the methods that I use during the warmer months to keep my fish healthy and growing, the methods that I used during the warm months accelerated the ice freezing in the winter months. And one of them is aeration. And what aeration does is it takes the air, which we would be taking air 20 degrees below zero Celsius, and putting it into the water. And what that did in my fish tanks, which I had 16 and 18 foot circular tanks, and that way I could keep a little current flowing around the circle. And the aeration, by blowing bubbles, my night air was often 20 below zero Fahrenheit. But the problem developed at a much warmer temperature. If I got down to, say, 10, 15 degrees Fahrenheit, and I was blowing that air into the water, it froze very quickly because it just bonded with the water in large part. It added a lot of oxygen to the water, but it brought colder water to the surface as those bubbles, 20-degree bubbles, were coming up through the water. It froze relatively fast. Now this could be done in the Arctic Ocean. Number of ways it could be done. It needs to be done on an experimental basis. Should have been done years ago, and it's a mystery to me why all these more educated people than I have not started doing that. But it works very well, and I'm sure it would up there. The problem, though, is to get the air, if you wanted to get the air down deep, because the deeper you are able to put it, and I don't mean a great depth, I'm talking 20 yards or 20 meters, whatever you want to talk. In order to get the air down, you've got to use some sort of a compressor. And I have done experiments in this recently, and when you use a compressor, unfortunately, it's hard to get a compressor that will build the pressure to go down there without actually warming the air that you're putting down there. So it could be done very well at somewhat shallower, up to 35 feet. There are some, well, they're not typically called compressors, but they're made for fish farming, and they will work effectively to 35 feet without creating a lot of heat. So at 35 feet, blowing masses of bubbles, say behind a ship with an aeration bar, maybe 100 yards wide, you would need several of these blowers in order to do that. But you could be reducing that section of water from the surface down to maybe 20 feet or so. You would be reducing that temperature dramatically from something above freezing. You're blowing bubbles minus 20 degrees Celsius through that water. You would, in a short period of time, in fact, if you're moving slowly with a ship, you could actually see an ice sludge building up behind the ship by putting that cold of air in there. Now, the other method that what I did during the warmer months is I had a very small pump, and it was aimed so that it would circulate the water in those round tanks. And in order to degas, because when you have a number of fish, the goal was to see how many I could raise in that water, so it was rather intense, and I relied on algae to clean my water and add oxygen as well. But one of the things that worked best was having these small pumps, and it was actually a half-inch pipe, and I would shoot that, actually heated the end of it and flattened it out, so it was shooting a flat stream. It's already breaking the water into finer bubbles, or finer droplets, and I put a screen up so that water, the screen was a foot or so away. It would shoot the water through the screen and create smaller droplets. And if I did that in the summertime, those droplets would be taking that cold air, 10 degrees, whatever, and by breaking it into smaller droplets, those droplets would be extremely chilled when they hit the water, and it wouldn't take long before I had an ice problem. So actually did away with the flared end and the screen, and I was able to keep, although I grew a mound of ice on the edge of that, and unfortunately I don't have any pictures of it, but anybody who wants to can go up there and improve it quickly by using a small fish tank pump and just blowing it through that air into, well, you can blow it on the ground. It's going to make a mound of ice relatively quickly. So a comparable thing here would be to take, and oddly enough, oil companies patented this in the 70s and 80s. They call it ice spraying. You can look it up. In fact, do a search on spray ice islands, because the oil companies, in order to form a solid base to put their experimental drilling rigs or exploratory drilling rigs out, they actually created ice islands that went all the way down to the seabed by spraying ice. So the only problem with this on a ship is that you want to keep the ship oriented so that it's not blowing this back on the ship, which I don't think is an extremely difficult thing, because they could extend these sprayers beyond the ship a good ways, and that would keep the freezing water from coming back on the ship and causing the ship to have a bad issue with that. So those are the two ways to rebuild something the size of Texas. It's going to take some time, but I think that during each winter, if we got a ship up there doing it on an experimental basis, I think we would be real surprised at how fast we can rebuild the ice. So if you know anybody who's in in that science area, or employed by, say, NOAA or even the Weather Channel, get them folks in on it. Pass this on. This is something that we do need to rebuild the ice. I won't go into all the details. You can check that out. There are a number of good videos out there, better than I can produce. But we need to get this passed around. So in order to keep it visible here on YouTube, I need you to subscribe, hit like, share it. This really works, and as I said, I'm not sure why our great scientists haven't figured it out, but maybe it's a simple matter of they never played with water like I have, and like a number of other fish farmers. And any fish farmer in the north can verify what I've said here. So let's get it going. This is our planet. We aren't going to be able to escape to anywhere else, which I won't expound on that, but let's do what we can for this planet. Thanks for watching.